Assalamualaikum warahmatullahi wabarakatuh. My name is Nabila Nadia binti Junaidi. Today I will present my bachelor degree project, which is a simulation and modeling the spray characteristic of biodiesel and ammonia mixture carbon neutral fuel. First, the research background, which is the rate of the hazardous emission was increased every year. This can be attributed to the increasing use of more vehicles. Hazardous emission can lead to the occurrence of air pollution, where it will have a detrimental effect on humans and environments. Many studies have been done to overcome this problem, include the discovery of alternative fuel that can be replaced with gasoline that can be used on vehicles. Among the alternative fuel that can be used are biodiesel and ammonia. Ammonia was one of the renewable sources and no carbon contents, and the combustion of ammonia only produce nitrogen and water as emission. But ammonia have a low latent heat and toxic properties, and with this advantage of ammonia we can overcome with the mixture of other substances. Biodiesel also one of the renewable sources, and biodiesel have a higher flash point and lower emission compared to diesel, but biodiesel have a higher viscosity. Other method that can be used to reduce hazardous emission is by the expansion of diesel engine. Diesel engine expansion is by better fluid air mixing as well as fluid droplet atomizations. The problem statement for this project is increasing food consumption and harmful emission for the traditional food sources, and ammonia is a good alternative fuel as it does not produce carbon emission, but it has a high latent heat of evaporation and low flammability, make it difficult to develop combustion system for it. And it was in this project cost of RCM was high to analyze the initial delay, which is we change address by using the CFD application to perform spray simulation of the biodiesel ammonia mixture. The objective is to simulate the physical flow pattern of a mixture of biodiesel, B30, and ammonia A2, F4, and A6 using the computational fluid dynamic, which is CFD, and to analyze the spray characteristic for different injection pressure of the three type of uh, bleeding ratio of mixture of ammonia, which is A2, A4, and A6 with the biodiesel B30 by using CFD. The scope of this project is the simulation is using three types of blending ratio of the ammonia mixture in with the biodiesel, which is ammonia A2, F4, and S6, with blending with biodiesel B13. The simulation are study based on the term of behavior of nozzle flow and spray characteristic, and the design spray nozzle injector have nozzle have a contain 6 holes, and the nozzle injector angle are at 15 degrees. later review, which is in the study in the journal of the spray characteristic of gallon propellants in sewer injector have found the influencing of the atomization behavior due to the nozzle diameter where there is a comparison of sprayer characteristic to two different of nozzle diameter injectors. In the journal of the numerical simulation of incipient cavitation flow in a nozzle of fluid injector, have found the combination of equation used to perform simulation of the initial cavitation of which only cavitation bubble clouds appear. And the question was large eddy simulation, LES, the Rayleigh placets with which is RP, and the Eulerian's Lagrangian bubble tracking method, which is BTM. And in a journal of a numerical study of the influence of diesel nozzle geometry on the inner cavitation flow, have found the cylindrical nozzle more likely to the cavitation, and the value of the rounding radius is lower compared to the conical nozzle. In a numerical analysis of injector flow and spray characteristics from diesel injector using fossil and biodiesel fluids, journal have found a lower and similar penetration traits over time can be indicated when diesel spray is injected from the cylinder bore and both biodiesel sprayers while diesel spray is injected from the conical bore with higher liquid penetrations. In the spray characteristic of pump biofuel blends, journal have found the soap bubbles and droplets undergo interaction in the spherical form due to the surface tension of the liquids. When the liquid and the gas interface becomes deformed and liquid droplet results, a spree is formed. And in a study of ignition process of diesel spray have found the ignition delay period can be influenced by the pressure, where high pressure will cause the ignition delay period to take a long time, unless in unless in the ammonia as a fuel for internal combustion engines. A journal has found ammonia have a very high auto ignition temperature, which is 651 degrees Celsius, and low flaming speed. The higher heats of the evaporation, narrow flammability limits, which is 16 in and to 25% by volume in the air, and also was a toxic. To overcome the disadvantage of ammonia as a fuel, ammonia will be mixed with other substances. The methodology of the process for this project was first we must modeling the geometry, which is this is a nozzle injector that we will use to simulate with the NSYS field, and then we will meshing the geometry, and then from the boundary conditions, we will input the boundary condition in the ANSYS fluent to run the simulation of the mix of the biodiesel and ammonia spray, and then we'll collect the data and plot the graph, and then analyze the data to see the spray characteristic.
model of nozzle injector has a six nozzle hole with each of the angle is 16 degrees. Diameter of each hole is 0.129 mm. This is the half part of the nozzle injector that will be used to conduct a simulations in the ANSYS fluents. This one first was the outlet. Outlet was the surface of the trigonal prism that parallel to the nozzle surface in a range for the pressure output. The outlet pressure is set as according to the pressure ambitions. Flow will occur after passing through the nozzle hole of the sprayer. And this one was the solid wall. The fundamental boundary condition that occur in the fluid flow dominant is known as the solid wall. And last was the inlet, the mass flow rate entering the dominance for the determine the value of pressure, fluid velocity, and even the mass flow rate, where the flow where mass flow rate is select as the entire option. For the result and discussion for the spray land penetration, from the simulation, we can see the impact of the temperature and density condition on the penetration length of the biodiesel and ammonia fluid mixture using the using the half of the orientation nozzle simulation. But by the observing that the emission density ammonia penetration are not too many, don't have many different between the three type of the mixture biodiesel ammonia. And the ambient pressure has a correlations with the expanding spray penetration length with the higher pressure resulting in a greater penetration. And the ambient temperature also have a significant impact on the penetration length with higher temperature resulting in a shorter length of the penetration and ammonia more being susceptible to the temperature changing. But in this simulation, we just use just fix the temperature to the 850 K. In For the spray angle of the angle of the spray is affected by the pressure and ambient density with a shorter angle observed as a lower pressure differences between the injector and ambience. The spray angle can be determined by the measuring the angle amplitude and using the vector and a contour starting from the nozzle. And the conclusion, this study is aiming at finding of the higher ambition pressure increases spray penetration in every particular circumstance. Then second, to for a spray penetration increases in the presence of the higher emission density. The third, the ambient pressure or density of the biodiesel ammonia don't have a huge impact and difference for the spray penetration length. And then higher ambient pressure lead to the greater expanding of the spray penetration. Then pressure and ambient density have an impact on the higher impact on the particle diameter and drop size. Smaller droplet size particle is closer to the spray tip, the higher the emission density value. After that, spray angle is also affected by the ambient pressure and density with a discrepancy changes in ambient pressure and increase injector pressure. Uh, Spray is resisted by the ambient density at an angle that is shorter as the pressure difference between the injector and the ambient decrease.